Hey guys, it's Apurva. Welcome back to another video. So, have you ever had a problem where you want to create a first person game but you don't know how to create a first person controller? Or you're an artist and you don't want to program anything but you want to see how your assets looks on the first person view or on a level. You need a controller to walk around the level. In that case, you have come to the right place, because in this video we're gonna learn how to create an FPS controller for your game. So let's start. Now let's talk about FPS controllers. The problem with creating a universal FPS controller is that you can't create a controller that fits for every game, because every game is different and every game needs different kind of controllers. Some game might need some features, some games might need other features. So there is no possible way that you can create a controller that fits for every game. But saying that, there are some common features on the FPS controller that fits vast majority of the games. Like, first of all, movement. Every FPS controller needs some kind of movement, the ability to look around with the mouse, jumping, going up and down slopes, stairs, in-air movement and stuffs like that. There are two ways to create FPS controller in Unity. One is using the RIGIDBODY component and other is using the character controller component. Now they both have their advantages and disadvantages. Using the character controller, you can already have going up and down slopes, stairs, in-air movement, and using the RIGIDBODY component you can already have the gravity inbuilt. So these two have different approaches in terms of building a character controller. So which one should you use? The easiest way to answer this question is, if your game has a lot of physics interactions, then go with the RIGIDBODY component, because physics is already built in the RIGIDBODY component. And if your game is more focused on movement, slopes and in-air movement, going through stairs, then use the character controller. But in today's video we're gonna use the character controller component. But if you want me to make a video using the RIGIDBODY component, make sure to comment down below or just hit the subscribe button, because I might make a video in the future, so subscribe. So here we have a simple scene with just a plane, some slopes and some stairs. Now what I'm going to do is create an empty object and rename that to player, and I'm going to add a character controller component to our player. Now if you have gizmos enabled, you will be able to see a green outline of a cylinder. That's our character controller. Now let's change some requirements for our character controller. So I'm going to set the height to 3.5 to make it a little bit taller, and the radius to 0.6 to make it a little bit. It's kinda hard to see our character or our player, so what I'm going to do is create a cylinder here and call that graphics, and I'm also going to remove the capsule collider from the cylinder, because our character controller acts as a collider. And now I'm going to change the scale of my graphics object to 1.2 on the X, 1.7 on the Y and 1.2 on the Z, so it kind of matches the height and the width of our character controller. Now what a character controller needs is a camera to see the world. Well, because it's a first person controller, we definitely need a camera. So you can either create a camera or just drag and drop the main camera you have already in the scene. So I'm just going to drag and drop the main camera onto the player and take it up a little bit so that it's kinda at the top but not at the very top, because I don't want my character controller to clip through ceilings when I'm jumping or when the ceiling is closed, and I want my character controller to be inside the graphics object so that the camera doesn't see this graphics object. Now I'm going to quickly create a folder called materials and create a red material called player and drag and drop that material onto our player so that we can identify our player a little bit better in the scene view. Now let's make the character controller step by step. So the first thing a character controller needs is the ability to look around with the help of the mouse. So if I move the mouse on the x-axis, I want my script to rotate the whole player on the y-axis, and when I'm looking up and down, I don't my whole player or character to rotate up and down. I want only my camera to rotate on the x-axis. So now that's out of the way, what I'm going to do is create a scripts folder, because I always like to organize my projects as you should, and I'm going to create a script called mouse look, and I drag and drop that script on our main camera and open the script on our Visual Studio. As I said before, the mouse can only move on the X and the Y axis. So first things first, what I need to do is get the mouse X and mouse Y's input. So in the update function, what I'm going to do is type float mouse X is equal to input dot get axis, and in parentheses I'm going to type mouse X and make sure the X is capital. This is actually default built-in axis in Unity. If you go to edit project settings and under the input manager, you can see that there's a mouse X axis and it's called mouse X. So whenever I type this command in my script, it refers to that mouse X component or mouse X axis, and I'm going to do same for the mouse Y, except this time in parentheses I'm going to type mouse Y with the capital Y. Now this input is very low, it can only go from 1 to -1. So if I try to move my mouse or my camera through this, the sensitivity of this is going to be very low, thus making it hard to look around. So we need to multiply this number with a sensitivity. So up here I'm going to create a public float called mouse sensitivity, and I'm going to default that to 100F, and I'm just going to multiply my mouse X with my mouse sensitivity. And since I'm doing this in update, I need to make sure that I multiply that with time dot delta time, because I want my mouse sensitivity to be independent of our frame rate, and I'm going to do the same for the mouse Y. Now let's give our player the ability to rotate on the X axis. So as I said before, while rotating on the X axis, what I need to do is rotate our whole player. So we need a reference to our player. So up here what I'm going to do is type public transform player, and in the update method I'm going to type player dot rotate and open and close parentheses, and in parentheses type vector3 dot up multiplied with mouse X. Remember, vector3 dot up means the Y axis. So when we want to look on the X axis, we need to rotate our player on the Y axis. This is how 3D works. Now if I save the script and go back to Unity and make sure to reference our player and play the game, you can see that we can look around on the X axis. Great. Now let's tackle the problem of looking up and down. So rotating the camera on the Y axis is not as easy as rotating the camera on the X axis, because on the Y axis we need to keep track of how much our camera rotates, because we need to clamp the camera's rotation between -90 degrees and 90 degrees, because we don't want our camera to look above 90 degrees or below 90 degrees. That's how it works. So first of all, what I'm going to do is type transform dot local rotation is equal to quaternion, and remember quaternion is Unity's way of handling rotation. So quaternion dot Euler and open and close parentheses, in parentheses I can type mouse Y, 0 0. But there's a problem here. Currently there is no way that we can clamp this rotation. So in order to clamp this rotation, we need a reference to this rotation. So what I'm going to do is up here type float X rotation is equal to 0, and I'm just going to set X rotation is minus equal to mouse Y. Now why I put a minus in front of the equal is because when I put a plus in front of the mouse or mouse Y, it inverts the rotation. So if you want to have an invert option in your code, in your games, you can do X rotation plus equals mouse Y, but we don't want that, so minus equals mouse Y. And I'm going to clamp this rotation by typing X rotation is equal to mathf dot clamp open and close parentheses, and in parentheses I'm going to first type X rotation and the value that we want to clamp between, so -90 degrees and 90 degrees. And lastly, I'm just going to change the mouse Y to X rotation. And now if I save this code and go back to Unity and press play, you can see that I can move around, look up and down, but I cannot look above 90 degrees or below 90 degrees. Now I want to solve a quick problem here, that is when I play the game the cursor is still there and it's kind of annoying. Solution to this is very simple. On the start method, just type cursor.lockState is equal to cursor mode lock, and that's it. Now if I play the game, you can see that the cursor disappears and I can look around the game. Now that looking around is out of the way, the next thing we need to do is the ability to move around. So in my scripts folder, what I'm going to do is create a new script and call it player movement, and I'm just going to select my player and drag and drop the script onto our player and open the script on Visual Studio. Just like we did on the mouse look script, we need a reference to our input system, or we need to check if the player is pressing the WASD key or the arrow keys. So in the update function, what I'm going to do is type float x is equal to input.getAxis open and close parenthesis, and in parenthesis type horizontal with a capital H. Again, this is not an axis that I made up, this is an actual axis in the input manager. You can look it up yourself, and horizontal actually maps to the A and D key and also the arrow keys and also the controller. And I'm going to do the same for the Z axis. Type input float Z is equal to input.getAxis, this time vertical, and this axis maps to the W and S key and also the up and down arrow keys. Now how we want to move our character or our player is we want to move our player locally. So to move our player locally, we need to do this in this way. So what I'm going to do is type vector3 move is equal to transform.right multiplied with x plus transform.up multiplied with z. Now while I was recording the video, I made a mistake and typed vector3 instead of transform. I later fixed that problem, so just type transform instead of the vector, but the vector3 move variable is going to stay the vector3. Change is going to be applied after the equal, and the way we're going to move our player is through the character controller. So we need a reference to our character controller. So what I'm going to do is up here type character controller, and in the start method I'm just going to type controller is equal to get component, and in pointy brackets I'm going to type character controller and open and close parentheses. So this is going to get our character controller from our player. So in the update method I'm going to type controller.move. This is a built-in function in our character controller. Move open and close parentheses, and I'm just going to reference our move component. Now it will be helpful if we could actually control the speed of our character controller. So up here I'm going to type public float speed is equal to 12, and I'm just going to multiply speed with our move variable, and since we are doing all of this in the update function, I'm just going to multiply that with time.delta so that it's independent of our frame rate. So this is where I fixed the problem of changing the vector3 to transform.right multiplied, and also I accidentally typed vector3.up, and that's also going to change transform.forward. So if I now just save the script and go back to Unity and press play, you will see that I can move around the world with WASD keys and also the arrow keys. Now if I move up the slope, you can see that I can move up the slopes and also the stairs, but currently there is no gravity applied. So what I need to do right now is apply the gravity. So right now let's work on that. So how we are going to check for gravity is we're going to have an invisible object at the bottom of our player that's going to keep track of if our player is touching the ground, and if our player is touching the ground then it's fine, and if not then it's going to apply the gravity. So let's create an empty object under our player and call it ground check and move it at the bottom of our player. And in our player movement script, what I'm going to do is create a new vector3 called velocity. So in the update method, what I'm going to do is type velocity.y minus equals, and now we need a variable for our gravity. So up here I'm going to type public float gravity is equal to 9.81, and I'm just going to set that equal to velocity dot y, and since we're doing this in update function, make sure to multiply that with time dot delta time. Now I need to apply the gravity. So down here what I'm going to do is type controller dot move. This time I'm going to type velocity and multiply that with time dot delta time. Now if I save the script and go back to Unity and press play, you will see that player falls to the ground and the gravity is applied, and I can climb through stairs and fall, but you will see that it increases over time, like the falling speed or the gravity increases over time. And if I change my inspector to a debug inspector, you will see that the velocity increases over time. That's because we're not currently saying the velocity to stop when we're on the ground, only to apply the velocity when we're above the ground. So now let's do that. So in Visual Studio, up here, first of all we need a reference to our ground check object. So I'm going to type public transform ground check, and also we need a layer marks to identify what is ground. So what I'm going to do is type public layer marks and simply type what is ground. I'm also going to need a ground radius, and I'm just going to default that to 0.4, and again we are going to need a bool that is called is grounded. So in the update function, what I'm going to do is type is grounded is equal to physics.text sphere. This is a default Unity method, and open and close parentheses, and in parentheses I'm going to type ground check dot position. So the sphere is going to be created on the ground check's position, and then we need a radius, so ground radius. And if we put a comma again, you will be able to see that there is an option to put a layer mask. So I'm going to type what is ground, and I'm also going to type an if statement. So if is grounded, so the player is touching the ground and velocity dot y is less than 0, then I'm going to set the velocity dot y is equal to 0. Now we can set the velocity to 0, but player might not start the game from the ground, so it's a good practice to set this to a really small negative number. So -2 is going to be fine for us. So there's an actual gravitational force always applied. Now I'm going to save the script and set the ground check object, and there is also the layer mask. So what I'm going to do is click on the layer. It says default, and I'm going to add a layer and call it ground, and I'm just going to select my environment and change the layer to ground, and I'm going to select yes, change children. So every object in here is now under the ground layer, and I'm going to select my player, and under what is ground I'm going to select ground. Now so applying the gravity is working just fine for us. So the next thing we need here is the ability to jump. So right now we're going to add the ability to jump. So with the ground check object already set up, it's very easy to set up a jumping system. So in the update method, what I'm going to do is type if input dot get key down, and open and close parentheses, and in parentheses I'm going to type keycode dot space. Again, this is an default key binding, and I'm also going to type and is grounded. So if the player is grounded and the player is pressing the space button, then we're going to jump, and the way we're going to jump is type velocity dot y is equal to math f dot square root, and right now we need a jump height. This is actually a formula we're applying to jump. So up here I'm going to type public float jump height and set that to 3, and in parentheses I'm going to type jump height multiplied with -2 multiplied gravity. This is an actual mathematical equation that we're using here. That's why there's a -2 there, gravity and the jump height. Now if I save the script and play the game, you will be able to see that the player is not currently jumping, and that is because when we set up our gravity, for the vast majority of the players, for easier to type, what we did is set the gravity to a positive number. But if you look at the gravity, it's a negative number, and on the velocity dot y we set minus equal to gravity, and that's because that's why the gravity works fine for us. But right now what we need to do is put a negative in front of the value of our gravity and change the velocity dot y to a positive number. So plus equals gravity, and I'm just going to type gravity negative in front of the gravity's value, so negative 9.81. For some reason I need to also change that number in the inspector, so just put a negative in front of the 9.81, and that should be it. That should actually work. So now if I play the game and press the spacebar, you can see that I'm jumping, and also there's an in-air movement. So great, you just made a first-person controller for your game, and that's fun, isn't it? And at the beginning of the video I said if you are an artist and don't want to program anything, and that is because this whole project is going to be, there's a link down below to a GitHub, so I'm going to upload this project on the GitHub so that you can download it and use it. Thank you guys for watching the video, and I will see you in the next video.